Hello, good afternoon everyone. Welcome to the class ECE341 Probability and Stochastic Process. Today we keep working on the pairs of random variables. Okay, so it's ECE341. This is for the next week, Friday's class. We consider two random variables, x and y. Then we know, actually we already learned something about it, right? Let's do a review here. We have the following. Actually, these are just for each x and y. You consider their single random variables. So we have CDF, we have PMF, we have PDF for each x and y. We have fx of x, this is, and fy of y. We have px of x and py of y. Of course, this is for the case discrete type, right? For discrete type. And then the density fx of x and fy of y. This is for continuous case, continuous type. You have this, we have this. And of course, for each one we have the values like expectation value, the mean of x and y, the variance of x and the variance of y, and we also have the standard deviation sigma x, sigma y, which are the square root of variance, right? We have this, and we have some joint thing. So compared with those joint things, we call these are marginal distribution. Marginal distribution. Right. Yeah, we used to call it this kind of distribution. We separated the 100% to overall probability to different possible values. Right. So it's a distribution. Right. Okay, then we also have the joint distribution. We have functions joint CDF, the PMF, and PDF, right? We have these three, similar with these three, but now they are joint functions. The CDF is capital F x and y of lowercase x and y. That will be the probability of capital X smaller than x and capital Y smaller than y. Right? This is this one. And the PMF, similar with CDF, just change this smaller than to be equal, right? Smaller than or equal to, now it's just equal to. The probability of these give us the value of this function pxy. And then PDF, denoted as lowercase f of x and y at value lowercase x, lowercase y. This is a limit when delta tend to be 0. Here's a fraction. The numerator is the probability of when capital X minus x smaller than half of delta, and y minus y is also smaller than half of delta. If you want, you can put delta equal here, it's also fine. Then divide by delta square. Okay, so this is a kind of a density, right? Average probability for a unit area. That you need that area tend to be 0. Of course, delta should be positive. Okay. So these are these 3 functions, and we have the relation between the CDF and the PDF. We have the CDF. We take derivative. Yeah, I should use this notation. I think last time I used D, but this is a notation for multiple variables. Right? We have 2 variables, so here's a partial x, partial y. We need to write it this way. This one gives us fx and y, and the other word we can say the integral of this fx is d y. This is dy tilde, and this is dx tilde. This give us this is lowercase f. This gives us capital F. Right. So we have these 2 relations between CDF and the PDF. Right. Okay, and there are distributions, and we also have some average values. We have a covariance of x and y, which is defined as expectation of x minus ex times y minus ey. Okay, we have this one, covariance, and we also have correlation rxy. It is just ex times y, okay, correlation. So we have these 2. Alright. Then related with these kind of things, we have some concept. One concept is independent. If in CDF, if fxy of x and y equal to fx of x times fy of y, x, y are independent. Okay, so in this case we call this independent. And we have 2 different versions for discrete or continuous type in the density function or the mass function, or like this, pxy, this is discrete type case, equal to px of x times py of y. Then this is also related with the x and y independent. And in the density function, this side is joined, this side is just the f x y, and this one same as x and y independent. Now we have these. This is one thing. Second thing is for the calculation, the covariance of x and y equal to e of xy minus ex times ey. Yeah, we have this formula. When you do the calculation, you want to find this one, you can use this formula. So far, I think, for the pairs of random variables, we already have this kind of result, right? We already have this kind of result. Today let's consider some this related with CDF. We have the example, right? Last class and the previous class, Monday, Wednesday classes, we have some examples related with PMF and PDF, but I don't have any with CDF. So here let's study something related with CDF. CDF, here I have an example in the textbook. Yeah, example 5.2. This is a example. We have X years is the age of children enter the first grade in a school, and Y is years is the age of children enter second grade. They have a joint CDF here. So this is the CDF. For this problem, we want to find the marginal CDF. From the joint CDF, we want to find the marginal CDF. But here I want to explain how. What is this one? What is this fxy? Yeah, here we have formulas, and let's try to represent it in a graph. I use MATLAB to do it. Okay. Okay. Let me put it in the notes first. Example. On CDF, we have f x y, x and y equal to several cases, right? Oh, it's windy. Okay, it will be 0, 0, x minus 5, y minus 6, y minus 6, x minus 5, and 1. We have 1, 2, 3, 4, 5, 6 cases. The first one is if x is smaller than 5, and the second if y is smaller than 6. Now here's x is between 5 and 6, and y is also between, it's different, y is between 6 and 7, and here you put the equal here, and then for y minus 6, according to x larger than 6, and y is also between 6 and 7, and x minus 5 related with 5 smaller than x, smaller than 6, and y larger than 7, and otherwise is 1. Right. Okay, I want to give a graph to show it, but before that we can look at here. Actually, these conditions give us the range for different values, right? So we can check how it looks like. X smaller than 5, suppose this is 5, x I need a value 5 and 6, and y I need 6 and 7. Alright, when x is smaller than 5, this is x equal to 5, right? This is x equal to 5. Then you have both sides. This side will be x smaller than 5, and this side is x larger than 5. And we will have 0 here. So all this part, f is 0. Okay, this is the first one. And the second one, when y is smaller than 6, y is smaller than 6, okay. This is y equal to 6. Smaller than 6 will be this side, right? The smaller than 6 is also 0. So this is also f equal to 0. And then when x between 5 and 6, x is here, and y is 6 to 7, y is here. So that means this area. When x and y satisfy this condition, the location of xy point will be here, and the f will be, I put it here, f will be x minus 5 times y minus 6. Alright. And then we have when x is larger than 6, okay, this is 5, this is 6, larger than 6, right? X larger than 6, and the y is between 6 and 7. So okay, so this part, right? Y is between 6 and 7, and x is larger than 6, or that part. Okay, so here's a y minus 6. Y minus 6. And this part, okay, x is between 5 and 6. 5 and 6. And the y should be larger than 7. So it is here. Right? It's here. And for this part, here is x minus 5. Otherwise, so only here. Right? This is 1. Right? This is otherwise. Right? We have occupied all of these should be 0. All of these is 0. And these two I have x minus 5 and y minus 6, and here's 1. And this part is a multiplication of these two in this area. Right. So the CDF should be a function looks like this. Okay, we can see how it looks like. Let's use MATLAB to do it. I need a function. Okay, I go to ECE341 code. Alright, let me edit file. It's a CDF2. Okay, CDF2.f. CDF2 does not exist. Do you want to create one? Yes, of course. Okay. For this one, I want a function. Function. I just say the same with the name, CDF2. CDF2, I will input x and y, and will return capital F. Return is capital F. Alright, return capital F. So how to return it? We have several cases. Right. We have 1, 2, 3, 4, 5, 6 cases. 6 cases. I don't need 6 cases. I can use it. We have this, right? I have this graph. You see the graph? Totally, the whole space I separated as 9 pieces, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. In the middle is x between 5 and 6, y is between 6 and 7. The upper part, y is larger than 7, and the lower part, y is smaller than 6. And the other direction, the left side, x is smaller than 5, and the right side is x is larger than 6. Okay, so totally we have 9 different pieces, and the value of f are different. For this part, all these three pieces with x smaller than 5, capital F is 0. And here, this also are 0. Yeah, we can use this later. So I gave these 4 cases, I gave special value, and all the rest should be 0. Okay, so I can write in this way. If x, let me see, x is okay, this part is both are larger than, one is larger than 6, one is larger than 7, that is 1. So if x is larger than 6, larger than and equal, larger than 6, okay, can I put a 6 equal here? Larger than and equal to 6, and in MATLAB, and this means and, right? And is that one. That is and, right? This is and y larger than and x larger than 6, larger than 5, larger than 6, and y larger than or equal to 7, then capital F is 1. This is one case. Else if now which one we can use? Actually, this 4 for non-zero values. So I can use this top one. The function will be x minus 5, and the area is y larger than 7, x between 5, 6. So y should be larger than or equal to 7, and x should be larger than equal to 5, and x should be smaller than 6. Alright, this is the case. In this case, f is something. Here's x minus 5, right? This area is x minus 5. X minus 5 equal to x minus 5. Okay, this is the second case. And the third case, else if now is we look at this part. Now y minus 6 part. So x should larger than 6, and the y is between 6 and 7. So I want x larger than equal to 6, and y should be larger than equal to 6, and y should be smaller than 7. Y is between 6 and 7. In this case, f is y minus 6. Good? Y minus 6. Y minus 6. Yeah, y minus 6. Okay, then we have a small piece. In this small rectangle, it is f will be the multiplication of these two. So yeah, I can move it. Then I can see both. Alright. Okay, so else if this is long, x should be between 5 and 6. So x larger than or equal to 5, and x should be smaller than 6, and for y should be between 6 and 7. So y should be larger than or equal to 6, and y smaller than 7. Am I good? Larger than 6, smaller than 6. Larger than 5, smaller than 6. They say x, and y is larger than 6, smaller than 7. Okay. So in this case, f will be is x minus 5 times y minus 6. It's multiplication of these two. Okay, then else. Then else f must be just 0. Right? All the rest is 0. Yeah. Okay. So this gives us the function f. And I want to show it. Right? This is just a function. Let me save it. Did it work? I click on it, right? It's wrong. I need to save it. Okay, save it. Give a name. Okay, just a CDF2. Yeah. CDF2. Save. Okay, and I want a new one. New function. That function will use this CDF2. Okay, just click this one, right? Make a new M file. Now I have a new M file. This file just use that CDF2 of x and y. But what is x? What is y? I need to give x, y firstly. In MATLAB, they have a function. They can give give the point looks like this. like this. Yeah, it lists the point like a grid, right? Like this one. That is a mesh grid. I think mesh grid. So I use X and Y equal to mesh grid. I want this, right? This is from 5 to 6, so I can run from 4 to 7. All right. So X run from 4 to 7. I use a step point 2 to 7. This is for X. And then Y, I will run from 6 to I need 6 to 7 for non-zero values, and I need more, so 6, 7. So I use 5 to 8. Okay, and step is also 0.2. Okay. Then I have X and Y. I don't know how many X do we have, how many Y do we have. I just use N and M to record the size of it. Size of X, that will be fine. F size of X. And then I need a F. F equal to there will be same size of X, so I just X times 0. So this gives us a vector F. The size is the same with X, but the value is only 0. Alright, then for I run from 1 to that N times M, because N and M, this is the size of X. X will be a square matrix, not square, it's a rectangle matrix like this here, rectangle matrix. So you have number of rows and the number of columns. I recorded in N and M. Now N times M, that is the total number, how many numbers in X, right? So I use this way. For I run from 1 to M, then I will run over all the element in X and Y. So here's a I, and here's also I. So every element of X and Y, I run the CDF2 and put the result in F of I equal to this. Okay. Alright, I have this F and what happened? Sorry. Okay, and then end. So after this for loop, we will have the value of that F. Now I will display it, but now is a function of two-dimensional function, right? Two variables. So the function is a surface. One is X, one is Y, and one direction is F. Okay, that should be the result. Let me save it. And this one is also and you save it. This is I don't know why. Just this is which one? It's V2. Okay, two variables. Just V2. Okay, simply V2. I save. Now let's run V2. In the command window, I put V2. Okay, this is the result. I can turn it. You see? Yeah, this is the function. CDF. This is CDF. You see? We have surrounded it. It is 0. And when X and Y large enough, it is 1. Right? These two sides is 0. Here's a 0. The dark blue is 0. And then the color tend to be lighter. That means the value coming up and up. Okay. Yeah, you can turn around to see. Okay, different direction to see. So this is the CDF. This is CDF. All right. Here we have the 1, 2, 3, 4, 5 different pieces. The highest value, this piece is f equal to 1, and the lowest area here, f is 0. And these three pieces, the value depend, right? Depend. One side is x minus 5, one side is y minus 6, and in the middle is a multiplication of that two factors. So this is a kind of a typical CDF. Typical CDF, it will looks like this. All right. Yeah. Yeah, it looks complex, right? It's not hard, but it's complex. You have to pay time to find it if you want. Okay, then for this one, if you want to find, we can find something like you can find the marginal distribution. That will be just in the bound, you know, like this side. It will be 1, then y minus 6 or x minus 5, then 0. You know, so this is marginal one. Okay, I listed it. We have more formulas actually. I list the formula here in case. Okay, for some formulas. Formulas for the marginal distribution. In CDF, we have f(x) of x. This is marginal distribution, right? And this one actually it is related with f(x) and y of x and y. How do they relate it? You just remove this y. You let this y go to infinite. That's it. Yeah, let y go to infinite, of course, positive infinite. Does it make sense? You can see what it is. This is the probability of x smaller than x, and equal. And this one is a probability x smaller than x and y also smaller than y. And let y go to infinite. You see, are they same? Same, right? In the left side, we only restrict the value of x. X can no more than lowercase x. Y should be anything, doesn't matter. And this side, yeah, y also need smaller than lowercase y, but lowercase y go to infinite. So that means nothing restricted the value on the y. So y could be any value. So actually these two events, they are same thing. Got it? The same thing. Okay, so of course they are same. And similar, we have fy of y will equal to limit. Now let x go to infinite. This is f(x) and y, x and y. Now you let x go to infinite, then you will have the marginal distribution of y. This is in CDF. We also have similar thing in the mass function, the PDF. This is in CDF. And in PDF, we have p(x) of x. What it is? This is related with p(x) y of x and y. But now we need a summation. Summation of for all y. For all y. Yeah. You let this all of this y to summation. Then you have this one. And remember we have a graph. Here's a p, x, and y in the middle, and we do suppose this side is x, this side is y. X has different value. we do summation in this direction, we do summation, then here will be px of x. And we do summation in this direction, then we have py of y. We do summation. So px is pxy, do summation for all y's. Here are y's, right? y1, y2, whatever, right? All the y's. You do summation along all the y's. Result is px of x. Px of x. And similar, py of y, here will be what? It is also a summation for this pxy of x and y. But now we need to keep y. Here we have y. You need to keep y. And do summation on x for all x. Now after summation, you only have y, variable y here. X is used. Okay. And then this is for mass function. This is PMF. And for the CDF, now we have similar thing. Just rewrite these, use the density function, CDF. Or equal to, okay, now it is not summation. Similar with these, but not summation. You need the limit of summation. That's integral. This is f, x, and y, dy. This dy, similar way here, summation for all y's. Okay, same meaning, like dy. And the y run from negative to positive infinite. That is meaning is for all the y's, right? Y run all the values from negative to positive infinite. And similar, we have fy of y. There will be integral from negative to positive infinite of f, x, and y. Now it's dx. Okay, this is for CDF, PDF, probability density function. All right. So we have this. Okay, so we have this. So for we have some formulas for marginal distribution. We can have these things. When it is necessary, you can try to find the marginal distribution based on the joint distribution. Okay. Then the second thing is about CDF. Still about CDF. If you want to calculate the probability, you want to find probability from CDF, joint CDF. The capital F, X and Y, So we have these. The probability of A smaller than X. I use A1 smaller than X, smaller than equal to A2, and the B1 smaller than Y, smaller than B2. This one, you are equal to F, X, Y of A2, B2. This is a large number, right? A2, B2, the upper bound. And the minus f, x, y. I keep A2, but B use the small value, B1. And the minus f, x, y. This time A use a small number, but B is still a larger one, B1, B2. And then plus f, x, y. Here both x and y, they are in smaller size, A1 and B1. Okay, we have this formula. We can use a graph to see. This is A1 to A2. This is B1 to B2. This side is X, this side is Y. Suppose we have the event is like this. Then you see, this one is here. I put a square here. Okay, this is this point. And the B2, A2B1 is here. and A1, B2. A1, B2 is this way. Here's a diamond. Okay, diamond, this point. And finally, we need to subtract these. Use a what? I put a star here. A star here. So the whole probability of this event, this small rectangle, it will be the CDF at this point minus at this point minus CDF at this point and plus this point. Make sense? Okay, I put more. For this one, for this rectangle, actually it is a probability of all of these, right? It is a x smaller than a2 and y smaller than b2. Here's a a2, b2. Right. So rectangle term is just this one, the probability. So here need to go to infinity, right? This one. And the triangular similar, but is this part, the triangular one. Triangular one is this area. Now A2, B2 is here, and here is A1. Oh, this is not triangular. This is A1, B2. A1, B2 is which one? A1, B2 is the diamond. Diamond one. Okay, it's this one. It's this. So you see, the rectangle subtract this one. You need to remove this part, right? This one is here. You remove it, you subtract. Then you have this bar. And then the triangular will be this part. Triangular will be here. Triangular will be here. This is triangular one. You need to remove triangular one. Also remove the triangular one. So you move these two pieces. But then this part you remove two times. Right? When you remove the diamond part, you remove it. When you remove the triangular part, you also remove it. So this part you remove two times. You need to add it back. You need to add it back. You only need to remove one time, right? So you add it back. You add this. Okay. Then you have the rest part, the probability of the rest part. Yeah. Of course, this formula just for the case you want to consider event can be described in a rectangle area. If you consider some different event, use CDF to calculate the probability is not so easy. For example, we have one example before. We consider x plus y smaller than 1, right? We consider this one. This event, what is this event? This event is here. X plus 1. Here is x plus y equal to 1. And smaller than 1 in this part. This part. And this part, if you want to use the CDF to find the probability, is very hard. Hard to use CDF. Alright. Yeah. So actually, I don't give you any homework problems related with the CDF to find the probability. But I have in the homework I have some examples. You need to find the probability based on the PMF or PDF. And how to do it? You can check previous classes. I have example there. Right? Okay, so this is the CDF, and we have some properties about the CDF. You see the graph. Actually, this graph can show us this property very well. So let's see some property of CDF. We have these: the f, x, y. If both, I write this way, if both x and y they go to infinity, then this one should be 1. Alright. That means another okay, this is not so exactly correct. It should be, people might be like writing this way: x go to positive infinite, the positive, and y go to positive infinite. Then you have f, x, and y. This is 1. Now, maybe you want this. Yeah, both go x, y go to large enough, go to infinite. This will be 1. And CDF, oh, I put all of them. And PMF and CDF, we have all of these, right? So for CDF, we have this one, and we also have f, x, and y. If they go to negative infinite, this is x go to negative infinite, and this is sorry this is x go to infinite, but y could be anything, and this will be, let me rewrite it, this will be f, x, and y. X could be any value, but y go to negative infinite. This will be 0. Yeah. This will be 0. Oh, sorry, it's covered by the graph. Is again. Yeah, CDF, when both x and y go to infinite, the limit of this capital F should be 1. And if one of it, this I writing this way, that means x go to negative infinite, and this way means y go to negative infinite. Then the limit of f should be 0. Yeah, should be 0. And also f, x, y of x, y are increasing when x, y increasing. Right. You can look at here. You go along this way. Now it's x increasing. Okay, the f is increasing. Right. It's go like this way. If you let y go to y increase, then the value of f is also increasing. Right. Yeah. What else? Yeah, that'll be okay. You can write one more. The value of these should be between 0 and 1. Between 0 and 1. Right. Yeah, they're probably similar ways the CDF of a single random variable. And then for the PMF, we'll have 0 smaller than or equal to pxy of xy smaller than equal to 1, and the summation of all of these will be 1. Here's all x or y. For all x or y, it is summation will be 1. That means the overall probability is 100%, right? Then for fx, the density function, fxy, we have similar. This word larger than 0, but we don't know whether it is smaller than 1. Maybe larger than 1. The density is larger than 1. The probability will be a density take derivative, take integral. The integral may not over 1, but itself may be larger than 1. So we only know it is larger than 0, but maybe smaller, maybe also larger than 1. We do not have this part for the CDF. For PDF. For PDF, we do not have this. We only have the larger than 0 part. And also I have this. There will be integral of f xy. This will be 1. Alright. Okay, that's all for today. And see you next time. That'll be next week, right? So bye bye. Have a good weekend.